Hello there, welcome back to another video, and today we're going to be continuing with integration, and specifically we're going to be talking about the difference between definite and indefinite integrals and how they might change the way you solve a problem. So let's get right into it. And before we start anything, I feel like this is a theme with every single episode so far. We start with derivatives before integration, and this will make sense. But let's solve this problem first. Okay, well this should be quite simple by now. The derivative of x squared plus 2x plus 2. So derivative of x squared will be 2x plus derivative of 2 will be 2. And then since 2 over here is a constant, we forget about it. So this right here is our derivative. Okay, well that was really easy. Let's go into the next problem. Okay, now as you can see, we have an integral problem here. And this right here is, I've used red to symbolize indefinite integrals. So this right here is an indefinite integral. So let's see what exactly it means here. So I got 2x plus 2, and I want to integrate 2x plus 2. So let's use the inverse power rule to integrate 2x plus 2. So we get 2x to the power of 1, and then we add 1 to the powers, so 1 plus 1 divided by 1 plus 1. So we get x squared. Okay, so far so good. And then 2x to the power 0 plus 1 divided by 1, so we get 2x. But that isn't the same as what we entered, right? Where did this 2 go? That's the thing. So what we've just done is we found x squared plus 2x. But the constant term right here in the first question is not there, which is why if we have an indefinite integral, we want to put plus c. Now plus c, all plus c means is just some constant. So this isn't the full equation, but we can assume there's some sort of constant here. In this case, if we were to take this equation here, our constant would be 2. But it could be any constant, because it doesn't matter what the constant is, as long as it satisfies these two constraints. It can be a derivative. It can be an integral of this 2x plus 2. So this is an indefinite integral. So always remember, if I have an indefinite integral, I will definitely have a c. And the way to remember this is indefinite is similar to incomplete, and the only way I can have an incomplete problem is if I still have a variable in my final answer. So imagine it that way. If my integral doesn't have numbers over here and here, then I will have a c. So just remember that. That's a very common mistake that many people make. So keep that in mind. Now going on to the next problem, I want to start it the same way as I started my other one. So I want to use inverse power rule to calculate these two values. So I get 2x, and that's to the power of 1. And then I add 1 to the power, and I add 1 to the denominator, which gives me x squared. And then I have 2x to 0, add 1 to the power, add 1 to the denominator, so I get 2x. So then I'm left with x squared plus 2x. So we end up with x squared plus 2x. Now, at the end of this problem, you won't have a plus c. And let me show you why. So let's say I do have a plus c here. And I can finish this off with a bracket saying this goes from 0 to 1. And basically what's happening here is my graph looks something like this. This is at 1, this is at 0. I'm trying to find the area over here, right? So the first thing I want to do here then is plug in my upper bound. If I plug in my upper bound, I get 1 squared plus 2 times 1 plus c. And I'll put that in a bracket. Remember always to put it in a bracket. Minus, and then I put in my lower bound. So that's 0 squared plus 2 times 0 plus c. And be careful of this minus, okay? I want to put all of this again in a bracket so that I don't confuse it. So then I'm left with 3 plus c minus c. And would you look at that? The c's cancel, which leaves me with just 3. And that's the process behind a definite integral. So in a definite integral, I will never have c because it's defined, which means I will come up with a final answer. So usually this is used when I have a slope and I want to find its area under the curve. between some certain points. So we talked about we talked about that in the last video, and this is sort of the process here. So just keep in mind, definite integral, no c. Okay then, going on to my next question here, I got 3x cubed plus 4x squared plus 2 plus 3x to the negative 1 dx. And as you can see over here, I have an indefinite integral. So if I have an indefinite integral, I need to know that it ends with c. So let's solve. First thing we want to do is do the inverse power rule. So we get 3x to the 3 plus 1 divided by 3 plus 1. So you get 3x to the 4 divided by 4. Then we get 4x to the 2 plus 1 divided by 2 plus 1. So we get 4x to the 3 divided by 3. Then we get 2x to the 0 plus 1 divided by 1, which gives us 2x. And then we have 3x to the negative 1. And again, be very careful with this negative 1. This is a trick question. And instead of something x to the 0, this will be 3 ln x. So this leaves me with my final equation, something like this. 3x to the power of 4 divided by 4 plus 4x to the power of 3 divided by 3 plus 2x plus 3 ln x plus c. Always remember the plus c. So indefinite integrals are quite easy to solve because you don't have to plug in any values at the end. So this right here is our final answer. Okay, that wasn't too bad. Let's do our last question then. Over here we got integral from 0 to pi of cosine x dx. So this is a definite integral, so we need to treat it slightly differently, but it's the same process in general. So what we have to do first is we have to find the integral of cosine x. So the integral of cosine x is sine x. Be sure to not be confused about your trig identities, because the derivative of sine x is cosine x, and the derivative of cosine x is negative sine x. But the integral of cosine x is sine x, because we move backwards. So it sort of goes like this: sine x, cosine x, negative sine x, negative cosine x. So if I take my derivative, it goes this way. So derivative, derivative, derivative. So dy over dx. And if I'm taking my integral, it goes this way. This is my integral dx. So over here, since I'm taking the integral of cosine x, I want to go backwards. So this time it's sine x. That's the thought process behind this. Now I have my sine x, so I can put this in a nice little bracket, and I can put my upper bound and my lower bound. So upper bound is pi, and my lower bound is 0. So what I want to do first then is I want to plug in my upper bound and subtract it from my lower bound. So sine pi minus, and then make sure to put it in a bracket. In this case, it doesn't really matter if we put it in a bracket or not, but once you get more terms, it gets more important to be organized with your working. And then you get sine, plug in the lower bound, so it's 0. And that leaves us with 0 minus 0, which gives us 0. Would you look at that? So that wasn't too difficult. Again, that was quite a simple problem. So that, I think, is it for this video. This topic isn't very complicated. It's just two different ways of solving integrals. Just keep in mind that indefinite integrals will always require c, and definite integrals always require organization. And once you get that down, I think it should be pretty easy. But that's about it for this video, and I'll see you in the next one where we talk about U substitution. Bye-bye.